Hi guys, tonight we're going to take a look at linear models and the equations of linear models. So we are going to look at this data right here on bridge thickness. So to the right are some results from a bridge thickness experiment. We're going to plot the thickness and the breaking weight data, where thickness is your x value and the breaking weight, that should say weight, is your y value. And then we're going to find an equation for the line that you drew. So first, let's start off by labeling our x and our y axes. And again, keep in mind, x is our thickness in layers, and y is our breaking weight in pennies. And you should always make sure that you label your units. So this y-axis is going to be our breaking weight. And that breaking weight is being measured in chickens. No, it's being measured in pennies. And then our x-axis down here is our thickness. And how are we measuring that? We're measuring it in layers. So let's go ahead and do the scale on our x-axis. I'm going to count by twos. So 2, 4, 6, and then 8, because our largest thickness in layers is 8. So this is 2, this is 4, this is 6, and then 8 layers. And our y-axis, I'm going to label by 5s. I'm going to skip count. So this would be 5, of course 0 is right here, 5, then 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And since it goes up to 65, we can extend our graph just a little bit, right about there. So now we're going to graph our data. We're going to graph the bridge thickness, and we are going to graph the layers and the number of pennies it takes to for the breaking weight. So for 2 layers, the breaking weight was 15. For 4 layers, the breaking weight was 30. For 6 layers, the breaking weight was 50. And for 8 layers, the breaking weight was 65. So we have to write an equation for the line of best fit. So that means we need to put the line of best fit in there using the eyeball method in this case. So if we draw in the line of best fit, our data looks fairly linear, and that's good. So we want to make sure we go through as many points as we can get through to make sure this is as straight as we can get it. And again, there it is right there. So we need to find the slope, and we need to find the y-intercept. So by looking at the graph, our y-intercept looks to be about 0. And then to find our slope, we want to use rise over run. And our y-axis is counting by 5, so it's 5, 10, 15. And then our x-axis, we're going from 2 to 4, which is from here to here. So our run is 2. So our slope is about 15 over 2. And again, this is an estimation, or about 7.5. So to write our equation, it would be y equals 7.5x plus 0. We can leave out the plus 0. So we're going to use this equation to predict the breaking weights of papers of paper bridges 3, 5, and 7 layers thick. So when x equals 3, I want to figure out what y is. When x equals 5, I want to know what y is. And when x equals 7, we want to figure out what y is. So if I take my equation, which is 7.5x, I'm plugging in 3 for x. That's going to give me 22.5, and that's pennies. And we would round that to about 23 pennies. 7.5 times 5 is going to give me 32. 37.5, and again that's pennies, which would round to about 38, and then y equals 7, it's 7.5 times 7, and that's going to give me 52.5 pennies, and that would round to 53 pennies. So again, this equation for the line of best fit is to use to make estimations. If we can estimate the breaking weight of a bridge that is 3 layers thick, the breaking weight of a bridge that's 5 layers thick, and the breaking weight of a bridge that is 7 layers thick.